Well, good morning, everyone. This is the Wednesday edition of CPT 168. Appreciate everybody being here. We're waiting on about 5 students to come to class, so they'll be trickling in here in just a minute. Hope everybody's doing okay. It's a beautiful day. It's going to be chilly, but it is February. And so I wanted to talk to you first this morning about the test that is due this week. And let me get a couple of things going here on my screen. Okay, we're almost there. Okay, so test 1 is due today. I sent you an email right before class to remind you. I sent you an email on Sunday to remind you, and it covers the first 3 units in the course. Right before class this morning, I looked at the tests that have, at least I haven't gone through the tests, but I looked at the tests that have been turned in so far. And it's about a half a dozen tests out of the 4 classes. So everybody's waiting to the last day to take the test. That's not terribly unusual. And I will tell you that most of the early test takers are making A's and B's. I saw 1 D and I saw 1 F and then 4 A's and B's. So if that'll give you any idea of what your competition is doing. Also, I wanted to remind you to kind of lower your anxiety that it's my practice, especially in this course, to curve our test scores to 80. So the course average will be 80 for the test. So that will bring up some of the scores, I guess, for folks that are still trying to figure out how to take college tests and things like that. It is possible, by the way, to make more than 100 on a test in my class. So that's a good thing. And that does happen, especially in this course. There will be some folks that will make more than 100 on this test. So the review sheet's posted, and all you have to do really is study the chapters and go through the review sheet, go through the terms at the end of the chapters, go through the summaries at the end of the chapters. If I were you, I'd review the quizzes in Blackboard and any notes that you might have taken. Certainly welcome to watch the lectures again if you want to. And, do as well as you can. Use the tools that are available to you. And I think everybody will be fine. It's a lot of terms and especially early on here, terms and syntax. Basically, there are some coding questions too. So please do not forget to take test 1 today. There's really no reason for any of us to miss any tests, especially during the pandemic, because I'm giving you 72 hours to take the tests. We're down to much less than that now remaining, but please make sure you have that in your schedule for today, your plan for today, that you take test 1. Also due this week is unit number 4. We're going to cover how to define and use functions and modules in today's class. Need for you to read and study chapter 4. Things are starting to get serious in this course. Last week and this week, we really started working on some programming, and I think you're going to find this to be a very interesting unit. If you've taken other coding or programming courses, you've seen how to create functions, but it's a little different. Every language does it a little bit differently. Syntax is different, but the idea is pretty much the same. You'll have a topic to post in the discussion board. I'm still working on getting caught up on grading. Unit 2 is really taking me a long time because I have to open up all of the labs in the idle IDE so I can see the code and grade them, which is slows me down a little bit, but we'll get that done as fast as I can, get caught up with you guys. You'll have another lab in unit number 4 here. Notice there's only 1 lab in unit number 4. There's not many units where there's only 1 lab. And that should tell you it must be a whopper of a lab. There are about 2 pages of instructions in the book on Lab 4-1. And so it's going to take you probably about as much time as 2 or 3 labs in one of the other units. But please take your time on it and understand everything that's coded in the lab. Review all the code. If something doesn't make sense, let me know. I'll try to point you in the right direction. It's all explained in the book, and we'll talk about it all in class, and we'll go from there. Also, you have your quiz for the unit. I think we're pretty much in a groove on the quizzes now. Everybody understands how that works, and that will continue for the remainder of the course. So, are there any questions about the to-do list for this week? I'll review it again at the end of the class, but pretty much a standard set of things for the unit, in addition to taking unit test 1 today. Anybody got any questions on that? I don't see anything. Let's see. Can I ask what format the questions are in for the test? David, the questions in the test are going to be multiple choice, fill in the blank. There will be coding questions. That's enough, I think, to put you in the right direction. Fill in the blank, short answer. You're going to have to spell properly and use the right syntax. Those are the hardest questions normally. Multiple choice, you'll have 4 or 5 detractors on those questions, and you will have some coding questions. So I hope that answers your question. Don't see anything else, so we'll go ahead and jump into unit number 4 in our textbook, how to define and use functions and modules. Interesting chapter. I covered this yesterday in the Tuesday class, and we got done about 5 minutes over time, so we'll be out of here fairly close to being on time today. We'll see how it does with this group. But today we're going to define a function, learn how to use the def, D-E-F keyword to define a function. And inside that function, we're going to learn how to code a return statement. And we will see several different ways that you can code functions when you're creating your own set of functions. We'll learn how to call a function. You've been doing that all along. I think we've been calling functions since the first week, and it's no different in functions that you define or create. It just gets a little bit more complicated as our functions get more complicated, and they will. And so we're going to learn something that is going to be very helpful. Named arguments are going to be very helpful in calling functions. So stay tuned for that part. From a program design and logic, we're really going to elevate the bar with this particular unit. We're going to introduce the main function. We're going to actually learn how to code almost our whole program in functions. And I don't say 100%, it's about 98% all in functions. And that is a very organized and professional programming style. You don't have to do it that way. I've told you before, there's certainly more than one way to get things done in Python and all programming languages, really. So I like this style because it's very organized. It's easy to debug. It's easy to maintain. But the main reason is, and we're going to learn in this chapter, that it is very portable. It's easy to reuse our code when we write our programs in functions. So we'll take a look at that today. We'll describe the use of the default values in a function definition. So instead of just having a nebulous value that we need to input, we can go ahead and predefine default values in the statements, and then statements that call that function, we can actually change that default value. Named arguments I touched on a minute ago. Perhaps the most puzzling part of this chapter is going to be when we get into global variables versus local variables versus global constants. And you're going to have to kind of open your mind up to think about this. Global variables and local variables are pretty easy, but the global constants part is something that I will try to explain to you, but it may be just a touch confusing. So I'm kind of a small red flag there. We will also learn how to document and create a module. Creating the module is super easy because it's the programs we're writing. I'm kind of getting to the punchline of the joke. There's nothing unusual about creating a module. It's just any file, any source code file that has a function in it is a module. Then when we want to use those modules, in other words, to import those modules, we have several different ways or things we need to think about as we import modules into our current project. And so we will deal with that in this chapter. Then we'll go back and take a look at standard Python modules again, now that we know more about how to create modules and maintain modules and that kind of thing. Going back to look at standard Python modules, the ones that are pre-built in our programming language, will be interesting. And we're going to learn a bunch of them. We're going to start with the random module today for we actually already learned some, but a new module that we're going to open up. We did the language module earlier. Let's see here. We were going to learn how to describe the problem that can occur when you import a module into the global namespace. There's certainly more than one way to do importation of a module. And so we want to make you aware of issues when we import the module into the global namespace as compared to the local namespace. And then the last little bit, we'll just take a minute, and that is how to plan the functions of a program and in turn plan your modules as you learn how to write those as well. So that's what's on tap this week. Unit 2, way back when, a long time ago, feels like a month, but it was only, 2 weeks ago, we looked at Unit 2. We learned a little bit about built-in functions in Python. And since then, we have started actually using modules a little bit. So in this chapter, we're going to learn how to define and use our own functions, how we can be smarter than the rest of these guys. We're actually going to create our own functions for our projects, and we will learn how to define those and maintain those. Then we'll learn how to store functions in modules, okay? We create the functions, store them in modules, and how to use those modules that we've created, that have been created by others, or how we can share our modules with other people. You know, if you write a really good module on XYZ and I'm doing a project that needs XYZ, I can download that module from your website, or you can email it to me and we can be friends. So we can share modules, which is very helpful. So by definition, pretty simple, a function is a unit of code that performs a task. That is about the most basic, simple definition you can think of. It is just a block of code that performs a task. And in many cases, it will be a repetitive task, something we want to do more than once. Not like a loop, that's not the same thing, but this function is something that we may want to use once or twice in a program or in a group of programs. So these, the writing of functions basically is planning and coding your project into chunks of code. Divide your code up into manageable chunks is the way the book says it. And that is, that's just good programming. It's good professional programming to be that organized. Makes it easier to maintain, test, and debug. You can use them in multiple programs. I've been using the word projects, same thing. But the main deal is we want to create reusable code that is so good we will want to use it more than once. And having written a number of projects, I can tell you creating functions makes your projects develop faster. And that is also something else that we need. We need speed in our development. So how do you code a function? How do you define a function? And it's really good to use the term define a function because that'll help you remember that in Python, we use the DEF command or keyword, a DEF statement. It is short for define, DEF. So DEF space, the name of the function, a set of parentheses. Inside those parentheses, we may or may not have arguments, okay? And then we terminate the function that we're defining with a colon. Now, after the colon, we indent the next line and start our block of statements that we want executed when we call the function, okay? So it's very simple. It's very simple. Just DEF, define the name of the function, parens, any arguments you want inside the parens, colon at the end, and then remember that colon kind of separates the statement from the block of code. Then indent 4 spaces in the block of code in the next line after the colon. Okay, it looks something like this. So DEF, function name, optional arguments in parentheses, a colon at the end of the statement, and then the block of code up under that indented 4 spaces. And it works really good. So there's a term that you're going to see over and over and over again in this book. Calling statement or calling function, okay? So that when you're calling, you want to execute it. You want to execute this function, okay? So to call a function, you use the same syntax for functions that you wrote, that you defined, as you did when you call standard functions in the earlier units. So there's no difference there. You just need the name of the function, code the name of the function on the left margin, and a set of parens. And inside those parens, you may or may not have arguments. It depends on how the function is written. And those arguments are comma separated, okay? Now, to be neat, it's kind of comma space separated, but you could do it with just a comma between those arguments. So our text gives us some examples, and we're going to see like a bazillion samples as we go along here, because they're the name of the game in this whole book is how to write functions and use functions. So how to define it, DEF. In this first example, we're doing a really simple function that doesn't even have any arguments. DEF to define it. Print underscore welcome. Notice we're using underscore notation to name the function. A set of parens. There are no arguments in this one. And yesterday I kind of got off on a tangent because inside those parens, I've seen different books call those values, arguments, and options, okay, and parameters. I saw them called parameters. So that's kind of ambiguous. This book is calling them arguments. So I will try really hard to use the same word that this book uses. I will try to use the word arguments. So inside the parens, optional arguments, and then a colon is required to terminate this whole statement here. Then we indent 4 spaces and we start writing our block. Now this block is pretty simple. It's just a print function with a string in it, and then a second print function for a blank line. To call it, you just print underscore welcome, which is the name of the function that we defined. And we have the parens with no options in them because we didn't require any. And it just prints the 2 lines, the 2 print statements. So you're thinking, well, you're having to do 2 things to get 1 thing done. And maybe it has a lot to do with style. It has a lot to do with being professional. It has a lot to do with reusing code. So kind of buy into this concept of using functions. I think it will pay great dividends for you. Moving on, here's a function that has 2 arguments, okay? And it uses a return statement. Now, return statement is required in a function when you are calculating a variable. You're calculating or creating a value for a variable. So those variables have to be returned out of the function. I'm not real sure. I mean, I keep going through the same chapters over and over in the book, and I'm not real sure that that is as evident as it needs to be in this chapter. Just realize if you are assigning a value to a variable inside a function, you're going to have a return statement to return that value to the rest of the program, okay? So you can see here that we are defining calculate underscore miles underscore per underscore gallon. And if I can have your permission, I'm gonna quit saying underscore. So calculate miles per gallon. And then we have two arguments here, and notice they are comma separated. So miles driven, comma, gallons used. So there are two. Now here's the gotcha that we're going to solve in a minute. These two arguments, when you use this function, you have to use the arguments in the same sequence if you do it this way. I'm going to show you a different way to do it in a minute. So, and there's the colon to terminate this statement. We got to terminate that statement. Indent 4 spaces start our block of code. So we do a little math here to come up with MPG. MPG has to be rounded. We're rounding to one digit here. And then we return that value, returning MPG. So I hope that you understand how this little function works. You should at this point, when we've done enough labs, that you should be familiar with this. So how to call this? Well, we have two functions that need the numeric literals. Miles equals 500 in this example. Gallons equals 14. So those are numeric literals here. And then now we can assign MPG using that function. We don't have to retype it. Calculate miles per gallon, and inside the parens, the variable miles, comma, and gallons, okay? And it will calculate. And notice these variables don't have to be the same names. They do not have to be the same names, but they have to be in the same order. So miles has to come before gallons. And that can be a little tricky when you get into functions that have 4, 5, 6, arguments. They can get complicated. So that return statement is in the body of code, the task that you want done inside the function. And you should code that return statement so it returns a value to the calling function, okay? It's just that simple. Now, one thing that the book doesn't say when we're talking about return statements, what if you have 2 variables or 3 variables or 4 variables inside that block of code? Then you're going to have a return statement for each of those. So the return statement normally comes immediately after you have finished manipulating the data, whatever you're doing, to assign the data to that variable. Once the assignment inside the function is done, then you have to have a return statement to return that value for that variable back to the calling statement, the calling function. So when you have one or more functions in a program, it is a good practice to put all the code in the program in functions. Now, when I am coming across a very prophetic statement that I want to make in my notes, I'm going to start italicizing them. I have boldness for keywords and phrases, and I'm going to use italics more in my notes. So I'm just going ahead and telling you that. And if you see underlining and italics, that's really important. So kind of follow my logic here. I'm going to raise my game a little bit on my notes, make them even more helpful, I hope. So this is a big deal. When you have one or more functions in your program, then do the whole thing in functions. Now, when you do that in Python, you need to have a main function, okay? To make that work, you put all the code that happens to not be in a specific function into a main function. The main function in Python runs the program. So you have function A, function B, function C, however many you have. Then you have a main function, any other house cleaning you have to do, any other details that you didn't cover in the functions, you do that. You do all your calling statements for all of your functions. You calculate all your values and everything in the main function, and then that runs the program. Now, typically the main function is the last function in your program. I've seen it. You'll see it in this book where it's the first function. It's normally the last, okay? If it's the first function, there's not a whole lot going on in the program. If it's a gutsy program with a lot going on, you're going to see the main at the end. So when all the code of the program is divided into functions, and then you have a main function, you need to call the main function to get the program to run, to start the program and run it. So we'll start off with some really simple examples and kind of build up. And since we have seen all this code in our labs already, we're going to focus on the yellow lines. So once again, our shebang line. Yeah, I've noticed, and you've noticed, that our book sometimes has a shebang line and sometimes does not. My suggestion to you and your projects, your programs, always have a shebang line because that gives you control over the interpreter / compiler that is going to run your source code. Okay. So this one is a real simple program. So we're just going to call the main function first. We're going to define it first. So we are going to display a welcome message. We're going to get our input from our users. You know, you've seen this before. Get the future value, do a little math here, and then print our results. And we want to round the results into 2 digits. Okay, so you've been dealing with the future value program. That the big lab 4-1 is, we're really elevating the future value program. We're adding more code to it, okay? So there are a couple of ways to call the main function. And you would think you could call the main function just like any other function. That's not true. This is not recommended, okay? You could, and it would work, but it defeats a very important part of Python when it relates to modules, okay? Because we want to be professional programmers and create modules, make our code reusable. So this will make perfect sense in a minute, okay? But the preferred way to call a main function is with an if statement. If 2 underscores, underscore, underscore, name, underscore, underscore, Boolean expression equals underscore, underscore, main, underscore, underscore, and notice it's in quotation marks. That says if this module is the main module, then run it, okay? Now, you're thinking, well, Bo, that makes no sense. I agree. We're going to get there. We're going to explain it. So the second way is a more professional way to call the main function. The reason is a module in Python is any file that contains reusable code like a function. That is a very important thing to get your head around, because we want to modularize, that's a tough word, to make our code reusable, make it into modules. That means that the file that contains the function, poof, automatically is a module. But what if you are importing that code into another program? You can't have 2 main functions, okay? That's the problem. If module A and maybe module B, however many modules you're importing into your program, if they all have main functions, then we got a problem, okay? So a simple if statement using these built-in variable names that are built into Python with the the double underscore notation there, that makes the magic happen, okay? So then if you run the module without importing it, and I am reading here to make emphasis, then if you run the module without importing it, Python sets its internal underscore underscore name underscore underscore variable to a value of underscore underscore main underscore underscore. That's the trick, the internal name variable. So we want to control that with the if statement, okay? So as a result, when you use that if statement, like the one we will see again here in the next example, it'll check whether the current module is the main module. And it does that by monitoring or tracking inside the compiler the name of the program that you are compiling, okay? So if it is, you call the main function as shown in the next coding example. If it is not, this means that the current module is not the main module, so you should not run its main module. So that, I don't know if it's worded all that well in the book and even in my notes here, but basically we only want to run the main module in the program that we are executing. We do not want to run any main modules that are in any, main functions in any of the modules that we are importing. So we want to run the main function in the current program, not in any of the modules we're importing. So everybody got that? I'm going to stop right here. I want to make sure because that's a pretty important thing. I'm looking at the chat. If you don't understand, let me know and I'll hit it again. Okay, no news is good news. Let's see, I got somebody coming into class. Yeah, we're going to have plenty of examples. We're going to have lots of examples, Joshua, so don't worry about that. I was confused reading the book. Now it makes sense. That makes me happy, David. That means I earned my paycheck today. I appreciate that. So yeah, this is confusing. Don't worry. We're going to understand this as we walk through it. And you're going to see it the rest of the course. So make sure you get your head into this. Christopher says, basically, in order to prevent other modules from running their own main functions all at once, you should use the if statement to make sure only the actual main module runs its main function. Yep. Couldn't have said it better myself. You are right, Chris. That's exactly how it works. Now, you're going to see something else that helps with this problem when we call the functions from the modules. That's coming up in a couple of more slides. So pay attention to that. I'll call your attention to it. But the two things together really keep the problem from conflicting main functions from happening. All right, so let's take a look at the future value program with functions, okay? So all of the code in the next example is within functions except the if statement. Remember I said about 98% of the code is going to be in functions. The if statement at the bottom is not going to be in a module, okay? It calls the main function if the current module is the main module. And notice they said current module. They really mean current program. The current source code is the main module, is the one that we're actually executing. All right, so we've seen this interface before. I don't think I have to explain it. It's still the same. We're going to make it better, but this is where it is right now. And pay attention to the yellow parts of the code here. So right up top, our shebang, and notice the next thing we're going to do is define. Now we're going to do some other stuff in this gap between the shebang and the first definition later in the unit, but right now we're not doing that. So def for define, and we're going to calculate future value. That's the name of our function we're writing. And we have three arguments: monthly investment, comma, yearly interest, comma, and years, okay? We still are at this place where we're going to have to, in our calling function, have to put the values for these three arguments in the same sequence. That bothers me as a developer. That's just too easy to screw that up. So, but just realize it's there, okay? Notice the documentation. We're getting better and better at our documentation here. Convert yearly values to monthly values. Calculate the future value. All this is the block of code. Notice we indented the for loop here, another 4 spaces, which is exactly what we learned to do in our previous unit. So all of this code should look familiar to you. Now, this return statement is new with this unit. So we have to have a return statement because we are calculating future value. That is the one variable that we're going to need as a result of this function. Could have more than one, but right now we just have the one, okay? So now we get to the main function. We have that function we just created. Now we have the main function. So the main function code is everything else that we need in the program, everything else that we need. So we got to set the value for choice. We start our while loop. I love the while loop. It keeps our console open, makes it very professional. So while choice, and we'll go ahead and run that through the lower method equals y. Then we get the inputs from our user. We've done that over and over. Get and display the future value. Now we are going to run our function. So future value is going to equal our function we wrote, calculate future value, and our 3 variables, which are arguments, and they have to be in the right sequence. These variables were assigned up here from our user, okay? So there's our 3 arguments. Then we have a print function here to print the result in a blank line. And then we have a nice little thing here to allow our user to continue and do this again, print by. And then we are out of our function here because now we're all left justified. Once we get rid of that indentation, that function's over with, the main function's over with. And so here's our if statement. That is the most mundane, simple if statement. The hardest thing about this if statement is to remember to code these variables on each side of the Boolean expression here exactly like this, okay? It's 2 underscores, name underscore underscore, equal equal, and then main, okay? Underscore underscore main underscore underscore. If that's true, then run the main function. This program does not do anything if we don't get this if statement to work, okay? Is that a good example? We have more, and you're gonna have a bunch when you study this chapter. Any thoughts? So, get rid of my circle there. When you define a function, you can assign the default values to 1 or more of your arguments. Now, back when I learned coding, somebody is slang, I know, but said, okay, we can hard code a value. That's what we're talking about here. We can hard code a value. And another way, a more professional way to refer to that is we can create a default value or set or assign a default value for our variables. Understand this, when we assign the default value for our arguments, the variables that are our arguments and our functions, that's easily overridden. We can override that default value when we write our calling statement, our calling function, okay? When we code that, we can, whatever we want the value to be, we can set it. So when you assign default values, you need to code the arguments with the default values after any arguments that do not provide default values. Now that is a gotcha. That one can trip you up, okay? So let's assume you have 3 values, which is our example. We have 3 parameters that we're gonna code in our definition of a function, but we want one of them to have a default value. That one has to be after the 2 that do not have the default value. Has to be after the 2 that have the default value. Screwing it up. has to be after the two that we do not have default values for. Then we have the default value. It has to be at the end. Need stronger coffee. So when you code an argument with a default value, you do not have to code the argument when you call the function. So what that is trying to say is when you write your calling statement, your calling function, anything that is hard-coded with a default value will pass through even if you do not code it in the calling function, okay? It will pass through. That may be a good thing and it may be a problem. So just realize any default value will pass through even if you do not call that particular part of the function you defined. And you can override them. All you got to do is just set the value for the argument when you call it. So here's an example of exactly what we're talking about. So in our calculate future value function, we're defining, notice at the end, we have two arguments that do not have a default, okay? We have the one argument, it has to be at the end. So unless this function is told otherwise by being overridden, years is going to equal 20, okay? That's what I was saying about hard coding it. And so, but we can override it. Now, here's the block of code, our math, okay? And here's some more of our block of code, just like we were doing. All this is the same in our return statement. None of this changed. All we did was really, this is the only change from the previous example. Now look at the calling statement. So the calling function, future value equals calculate future value 100, 8.5. Well, that assigns values to the first two arguments. Doesn't even mention the third argument. Well, that third argument, that years equals 20 is going to pass through. Or we can override that default value by entering the value for the third argument, okay? I don't know if that's going to be terribly helpful. Well, it's going to be helpful in the course, but in your programming life, I don't know if you want to do that or not. The thing that concerns me about things that happen that you can't see in your code is the code review. You know, when you pass your code over to some other developer. And so if you do this, at least I just think it needs to be documented. You need to have a comment in your code explaining how your function works. It's always good to explain your functions in your documentation. We're going to get even into that pretty heavy here in a minute. But even if it's just a simple comment, it's very helpful, okay? So let me put it this way. I would expect you as my student to always document your functions you define. Tell the village idiot that might be reading your code exactly what you intend to do and how it's going to happen in your documentation. That's just being a professional programmer. So a minute ago, I told you there's going to be a way to defeat this sequence of arguments issue in your functions. And it's all in your calling function because, and I think this is worth the price of admission to class today. This is important. When you call your functions, any functions, could be a standard function, but when you call your functions, you can name the arguments in your calling statement. That is huge. So all you do is whatever the name of the parameter is, the argument equals this value. You don't have to have them in the same sequence. So once again, it's back to documentation. So if you know the names of the arguments, it's so easy to populate the values just by using named arguments, okay? They don't have to be in the same sequence. And this is a huge way to cut down on the number of errors you're going to have when you are coding. So here's an example of what I'm talking about. It's the same future value function we've been dealing with. calculate future value. I mean, calculate future value is the name of the function, but this is the calling function, the calling statement. Future value equals this function we defined. Notice the parens here. The left parens is up here. And then notice the way this is laid out. You don't have to break it into lines like this. You could do it left to right, but this is just so neat. Years equals 10, comma, monthly investment equals 100, comma, yearly interest equals 8.5. That's reverse order from the way the function listed those arguments, and this would work. So the only thing I have to know at this point is the names of the arguments, and that can be taken care of in the documentation. Just one sentence of documentation telling me the names of the arguments, and then the function when you define it. Perfect. It would make it so easy to code the calling statements, and you wouldn't have any error messages. So I hope you're as excited about named arguments as I am. I just think they're important. I'm getting ready to change the subject. Has anybody got any more questions about defining or calling your functions that you define? Because this is going to be your genius from here on out. When you, as the labs get harder, they're going to say something like, hey, write a function to do X, Y, Z. They're not going to tell you how to do it. So David asked, I have a question about modules. If you were to write any code outside of a function in that module and then imported that module into another program, would the program automatically run the code? No, it would not. It will just run the functions. That's what's so genius about it, okay? So it's just going to ignore any outside code outside the functions. As long as you have it correctly structured, those functions are correctly structured, it will work. So that really makes your code portable. That's a nice thing about Python. Good question. We've had good questions in this class. I think this class, for whatever reason, is really getting it, including calling functions. No, they wouldn't run because it's a module. It's not in your main program. Nope. So when you, and we're going to get there in a minute, when we start working with modules, you're going to see all we're doing is calling a particular block of code a function out of another file. That's what it amounts to. Look to this file, get this function, run it inside this main program I'm writing. And that's all it'll run. It's cool. You're going to do a bunch of it, so you'll see what I'm talking about. So let's talk about scope just a second, because this is kind of high level stuff, okay? Scope in a programming language refers to the visibility of the variables. Where do the variables exist? You say, well, Bo, that just doesn't make any sense. This is all about functions, okay? Is the variable created outside the function or inside the function? Where is the variable created, okay? And or assigned or set, whichever term you want to use. So where it is assigned has to do with its visibility. And there's a right way and a wrong way to do this, okay? So global variables are variables that are defined outside of all functions. They're just left justified in your code, you know, XYZ variable equals 1, 2, 3, okay? So that would be considered a global variable. It's global because it's outside all of the functions. So those variables can be accessed by any function without passing them to that function, okay? Kind of put a pin in that. We're going to come back to that. In contrast, local variables are defined within the function. We've actually seen local variables in our last 2 or 3 examples, okay? Those were all local variables, MPG, future value, all that stuff were local variables the ones that we were working with inside the functions we were designing or calculate future value. So that's called local scope. Look at the very last bullet here on slide 30. In general, it is considered a good practice to avoid the use of global variables because they often lead to programming problems. This is not going to be a syntax error. It's going to be worse, okay? Because this is going to be a runtime error. This is going to be a logic error. You're not going to get the results that you're expecting out of your variables. So that should scare you a little bit. Be very careful about this. So define your variables inside your functions and then use the return statement to get the value out of the function to the rest of the program. That is the correct way to do it. So a couple of examples of local variables. Notice that we are right here assigning tax inside the definition of a function. So this is a local variable and we return it, okay? Here's an example without a return. We're assigning tax. It's inside a function. It's inside a main function in this case. That is a local variable. Here's how not to do this, okay? And this has to do with the global variable. Tax, lowercase, equals 0.0, okay? That is a global variable. We use the global keyword here to change the value of tax. Well, that's enough right there to make me not want to do this, okay? But anyway, you would have to use the global keyword here to access that global variable. Then it makes it possible for you to change the value of it here with this calculation. Okay, so now if we get down to the defining the name, notice that we have values here for this function. And when we run that function, we are going to get a tax of 4.25, okay, when we print it out here, when we call it. And here's the problem. Okay, let's just get back to the problem, why we don't want to run global variables. Because inside this function, we changed the value for a global variable. And that global variable may be called 2, 3, 4, 100 times somewhere else in the program. And we just changed it for all of that, okay? Rather than just changing it inside the function that we are trying to deal with, okay? That is where you're going to have your logic errors because now your program is not calculating properly. And you're going to have to go back and say, why is this thing not doing the math right? Oh, I used a global variable instead of a local variable. And it's not going to throw an error. It's not going to slap you in the face. You're just going to feel like a dummy until you see that that global variable's out there. So be careful about that. At least you have a warning, and that's this global keyword here. When you use that global keyword, realize you're getting out on thin ice, okay? So here is a local variable that shadows a global variable, okay? And when we say shadows, okay, we're not using the global keyword, okay? So here it is a global variable. In here, it is a local variable. Okay, this just got really confusing. They're named exactly the same thing. We're not using the global keyword. This is not going to change the value of that global variable. What is the problem? It is just crappy programming. It is too confusing, okay? So we should have a different name for tax inside our function here, okay? So tax is basically the same name used for two different variables. We have one that's global and one that's local. That is what shadowing a global variable is, okay? Not good, not recommended. Okay, let's make it even more confusing. let's get to global constants. Now, global constants are okay. These have a place in our programming logic. The key word here is constant. This is something that is never, ever going to be changed. If it is changed, it is like a 1%er. It's just changed very, very rarely. Okay. So there's a little trick here. Okay. And the trick is the name of the global constant has to be capitalized. Capitalize the name of a global constant. That tells everybody reading this code that that is a global constant. It is not a global variable. Then Python knows it's a global constant, and Python will make it read only inside the inside your functions. Okay, unless you do some really bad programming, you can break that, but typically it's read only. Okay, so let's see how that works. So you saw the global constant there, and you see that it's in all caps. Please remember global constants, all caps. Python does not prevent you from changing a global constant. You can still use the global keyword to change it, okay? Within a function, a global constant is read-only by default. To change it, you use that global keyword that we saw used on a global variable. In most cases, let's just say in all cases, this is a bad practice. It rarely makes sense for a function to change the value of a constant because it's a constant. It's not supposed to change, okay? The state tax rate in South Carolina is what, 6% sales tax. That's a constant. It's not going to change. It hadn't changed in years. So when you are running a program, set a constant for the sales tax if that's pertinent, and then you can call it whenever you want to. Just make sure you use all caps, and that will protect you. Okay. So I'm going to pause again because we're going to change the subject here and go to modules. So do you guys understand the difference between local variables, and global constants? Are global constants imported with modules? No. They're not that global. Don't think they are. Okay. You're going to have to create your own global constants in your main. Okay. Remember, we only use modules for the functions in the modules, nothing else. Anything outside those functions are not going to come into your main. I think that's an easier way to understand it. Now, I appreciate the fact that David and Chris, some of you guys have read this chapter before today, so we can have this meaningful discussion. And I think this helps everybody because we're seeing where the confusing parts are, and maybe we can hammer it out. Global constants never change. Global variables can be used by a function in the program, and local variables can only be used within the functions they exist. Okay. Yes, but, okay, Chris, do not use global variables. Just try not to do that. That is not a good idea to put a global variable inside a function. Just deal with local variables inside your functions. And I think that your results are going to be much more satisfying. Okay. The idea here is if you start using those global variables and you have a long, complicated program, and you can mess up other functions that you didn't even know you were messing up. See what I'm saying? So I don't think that's a good idea. But just stick with local variables inside your functions. Good question. Inquiring minds want to know. All right, so how to create a module, the easiest thing you'll ever do, because a module is any file, any source code file that has reusable code in it, like functions. The name of the module is the name of the source code file. Pretty simple, okay? So I guess the word to the wise there is make sure the name of your source code file you're going to use as a module says something. Make sure it makes sense to everybody what it does, what it is going to do for you when you import it into another main project. So many programmers will store their modules in a central location on their development computers. That's just good housekeeping, okay? You could just call the folder modules or Python modules. And there's one additional caveat, especially if you're doing some professional development. Make sure that the folder name, the directory name, if you're using Linux, make sure that's in the search path for your operating system. Whether it's Windows or Linux or Mac OS or whatever, all operating systems have a context of search path. This is the default path that the operating system is going to look through for any executables. Okay, and so you can, and you'll just have to Google it for your operating system, but it's not terribly difficult to add something to the end of a search path. You just have to find the right configuration file to do it in. And tread lightly on that configuration file. Make sure you have a backup copy before you start making changes on it. So that's search path. We teach that in other courses. Hopefully you've heard that before. So to create that module, we're going to get more into that main function because that will help you understand how modules work. So we will see in the next example why the if statement that calls the main function is so useful, because basically that if statement ignores the main functions that might be in all of your modules, okay? It's just that simple. So it only calls the main function in the main program that you are coding at the moment. So the code in this module that's stored in the temperature PY. Notice temperature PY is source code. It has a main module in temperature.py. That main module is there for one reason, for testing the two functions that were created in that module. Not really interested in this being a big time program. It is primarily just to have a couple of functions ready. Okay. So, and this is kind of cool because you can modularize your coding projects. And once you do your pseudocode and your charts and things, then you can jump around a little bit if you want to. I'm not saying it's a good idea, but some programmers do it. They jump around, or different members of a programming team will write different modules, and then they'll put them all together, and somebody will write the main to make all the modules work. And so this would be an example like that. We have two defined functions here. We're going to calculate to Celsius and to Fahrenheit. Then we have a main function here used to test the other functions. This code isn't run if this module isn't the main module. So this only runs if it's called from temperature PY. So we have a main function here. It just runs those two little functions we wrote as a test. If this module is the main function, call the main function. And so we have our if statement here, verbatim. We don't have to be creative here. Just memorize it. The key is those two underscores in front of name and after name, and two underscores before and after main. Main and name, name and main, and then call the function. Okay. Pretty simple. So here's the program output. When we do that, it just runs through and gives you a good test. Okay. Now, if you are going to do professional level programming, documentation is critical. And when you do your demonstrations or show your demonstration code in an interview, documentation is critical. So pay close attention in Unit 4 here to doc strings. Doc strings are a simple way to use Python as a documentation tool. Okay. This is so easy and yet so professional, because a doc string ends begins and ends with 3 double quotes. Okay. Double quote, double quote, double quote, docstring, bunch of words, sentences, paragraphs, and then 3 more double quotes to end it. That is a docstring. Use the proper indentation. Now, when Python decodes and compiles and renders your docstrings, the indentation is going to have a lot to do with how it's displayed, okay? So you can have basically a description of your program at the left margin in a docstring, and then have a docstring in each of your functions explaining what they do. And then to display those docstrings, start your shell, import the module, and then pass the name to the help function. We'll see that right here. So here's the coding example from the book. Double quote, double quote, double quote, 3 of them, a bunch of words, and then 3 more double quotes to end it. So that's the description we'll see here in a second. Then we have another docstring here in function A, and in function B explains a little bit about what they are. Yeah, we would need a little bit more, documentation really to be world class here, but they're showing us how the docstring works. And then here we haven't even really gotten into this, but the import keywords, how we import in a module. Okay, so import the module into the interactive shell for idle, and then run help on that module. Help is a function. Inside the argument here is the name of the file or command or whatever that we want the help on. And part of the help function is to decode those docstrings. So we see the name. Look at the way it comes out. Help on module temperature. Okay, so it gives us the name, the description, that first block, and then we see explanations of each of our functions. That is just real professional programming there. That's really good. So we just remember docstrings. Those are going to be helpful to you. And I don't think you're going to see a whole lot of, oh, by the way, did you do your docstrings? But then you're going to see when you do your code reviews, or you're in a programming team, I'm glad you document your code and use those docstrings. That helps so much, especially in your modules. There's the docstrings in this example are for the reusable code. Okay, so before you can call any of the functions in a module, you have to import that module into your main program, okay, whatever it is you are working on. So there is an import statement, and there are a couple of ways we can play that import statement, the way we can code it. We can do just a real simple import XYZ, whatever the name of the module is, and that will bring it into the global workspace. But we can also put that module, we can put it into a very specific namespace. Now, yesterday I tried to explain this, and I don't know, I might have made this more complicated than it has to be, but the writer of our textbook uses the word namespace like that is something we use every day. But basically what this means is you can import the module and then you can change its name. You can give it an alias. And that is what he's referring to here by specified namespace. And to do that, we use the as keyword. You'll see an example of it, okay? So the global way is to import module names. So from that point forward, when we want to call any of the functions in this module, we'll have to use that module name, or we can use the as keyword, this is optional, and change that namespace to a specified namespace, which is something that is convenient for us, okay? So here we're doing the global way, import temperature, and look at the call. When we want to call a function, this is the calling statement, we have to code the module name, a dot, and the function that we want from that module. Module name, dot, and the function name that we want from that module, okay? Now, to specify the namespace, okay, as temp. Same coding, but we use the alias here that we created. This may actually save you some time, and especially if you have a bunch of different versions of a module or something, there could be different problems that can be solved by using the as keyword and using what the writer of our book calls specified namespace, but really it's just an alias. You guys understand that? It's pretty simple, I think. So to import into the global namespace, you can use a from variation of the import statement. This is not necessarily a good idea, but typically we kind of do, okay, I just want to have access to all the functions, but all the functions in a module, but we could specify which functions we want to import. That may help. And if you do this, if you use the from keyword in your import statement, then you don't have to use the name of the function when you refer to it. I just don't like that. That makes the code harder to read. It's harder to understand what you're looking at. When you've never seen the code, it's just so easy to say, okay, I'm importing these modules now. When I see references to it, it makes sense when you're reading through a program. So if you import functions from more than one module into the global main space and two functions have the same name, now we got a problem. Okay, so that's why doing this whole from variation is talking about here. That's what's going to create the name collision when you have multiple modules coming into your main project that you're working on. Now, I know we're talking about things that are down the road for you guys, and you probably are not going to have to worry about this anytime soon. But just realize that we have to protect the uniqueness of our function names. And so if you have two functions that are imported with the same name, you're going to get all kinds of problems. You're going to have the name collision. So notice our writer says not recommended here, but we can use this this from keyword here. From this module, import this function name, and this function name. Okay. And here's an example of it. From temperature, import to Celsius. So here's our module and here's our function. And then when we call this, we do not have to be so specific in our calling statements, okay? So another way to do this is use an asterisk when you use the from. I just think that from keyword to not have to refer to the names of the modules in your code, it's just going to be confusing and it's going to create problems. Is it possible to give the duplicate function names a nickname or alias? Just use the as keyword and then use the name of the function when you call, the name of the module when you call the function, as we saw in the first example, and that's just going to clear it all up. Then think of it like the path to a file. You can have the same file name in multiple folders or directories on your computer. But when you refer to them, you've got to refer to the folder that holds it. And that is exactly the same thing that's going on here. So I don't like this from keyword for myself. But as a teacher, I got to teach you these different options. Name collisions are a bad deal. Our name collisions, what happen with main functions if they don't use the if statement. Not necessarily. Okay, I'm going to go out get on the fence here. I don't think that's what you're going to see if you don't use the if statement. I think you have bigger problems. I think it's going to be bigger than a name collision. Just don't use the from keyword, and then you won't have a problem. That's really what the book says. Okay. I don't know if that was a good answer or not, but I just don't think it's a good idea. All right, so let's look at and there's bunches of program code in this unit, and I'm not going to go through all of this. I'm going to give you bits and pieces and let you do the heavy lifting, because we're at that point where we are going to have to elevate our skill here. It's getting real. So let's look at the convert temperatures program. We'll see the import statement to bring in the temperatures module, and we're going to change it to the specified namespace temp, give it that alias, and then we will refer to those functions that we've already seen. Note that all the code in this program is in functions except for the import statement at the top and the if statement for the main at the bottom, okay? And that is very typical. That's why I said 98% will be inside functions. Now, another thing that the writer makes real clear here, I think, is that it's a good idea in your main program to, when you're writing or defining your functions, to define them in the order in which you need them in the main. So in the logical order that they're going to be used in your program. That just makes it easier to read your code. It's not required, okay? It's just a good practice, okay? So we'll start off with the display, then we'll convert, we'll use our functions, then we'll display, okay? So here's a nice little program. I would like to point out, let me stand up for just a second. My back gets tired. Oh, okay. That helped a lot. Thank you. Didn't want to freak you out there too much. I had to stand up. So notice the menu. A new coding thing that we need to get good at, because we need to give our users options. And so we're using menus here. So look at the logic in the code, how that menu works. And so we have to decide which way we're going to do the temperature conversion. And then we really just enter a temperature and give a result. So it's a very simple little calculator. And then you give them a chance to go again and convert. Very user-friendly, I think. And it's using that while loop to keep the console open. So here's our code, and we'll just look at the important stuff. Here's our import statement. This is outside a function, so import temperature, and let's refer to this as temp. The as keyword changes to the specified namespace. This is global namespace, specified namespace, to follow along with what the book says. So we have a display function that's just going to print the menu for us. Then we have a convert temp. This is kind of the meat and potatoes part of the program. So define convert temp. And notice rather than using arguments in this function, it's using if statements, which makes it even super easy, much easier to do your early, maybe the coding on your early functions as you learn how to do this. So we have an option that we are going to assign here, and we have an integer function with the input function inside of it. So we collect this information from our user. There's our user prompt. So if the option is equal to 1, then do this block of code. Else, if the option is 2, do this block of code, or else print, you must enter a valid menu number. I said this yesterday. I'm still thinking I'm right. Make this as user-friendly as you can. Be nice to your users. It'll make your life easier if you're nice to your users. So think of ways that you can tell them that they screwed up without insulting them. Okay, I just think that's a good idea. So define your main function here. Okay, so we're just calling our function. So the calling statement here for the display function. And realize in the main function, you're going to have all the code that's not in the other functions. So we have to assign the value of again to y and write our while loop to hold the console open. So again, okay, again, we want to convert that through the lower method to lowercase y, and or to make it a lowercase y. And then convert the temp. We're calling that function. We're going to print And then we, because this is such a simple little program, we have another input here to decide whether we're going to go again or not. And then there's our if statement. This is the magic, so that we are running the right main program, and we run the right main function, I should say. It's in the main program, but the right main function. So it's not rocket science, as they say. I think it makes sense the more you use it, and you're going to get really good at it. And that is, to me, maybe the most significant part of the design up to this point in our course, programming design and logic and design it is. All right, so how to use standard modules. This is exactly the same way. You just bring in standard modules. The hardest part about standard modules, since you didn't write them, you're going to have to know what the name of the module is and what are the functions in the module and how do those functions work. Well, that's basically Python 101 stuff there. You can Google that. You can look it up in a book. There are lots of ways to get that information. We're going to start off with the random module, okay? Our course, this textbook uses these 6 standard modules a lot, okay? In our course, we're going to use the first 5. We're not going to use the 6th one the way we have a 14-week course laid out. If we had a Python 2, we'd get to the GUI apps, but right now we're going to concentrate on the first 5. And notice the second one is random, okay? So random is all about generating random numbers. So we need to know, what does the random module do for us? Well, it creates or gives us access, I should say. It provides these 3 functions. Now you would think, well, Bo, there's the random function. That should be the one I will use. The problem is it returns a float value. Now that may or may not be a big issue for you, but my motto is don't use float values unless you have to, okay? We don't have to if we just want a random number. So that takes us to our go-to, probably the one that we're going to use the most, the go-to function here, rand, R-A-N-D for random, I-N-T, integer. And we give it a low and a high, a minimum and a max. And it will generate a random number between those 2 numbers, those 2 integers that you enter for the minimum and the max. Couldn't be easier. Super simple. Okay. And you're going to use that in the pig dice game that you're going to work on in Unit 4. Okay. So the last one there is the same. It is a range. Okay. Rand range. So you have the possibility of a start number. You got to give it a stop number. And you have the possibility of a step if you want to step through the range of numbers. To me, at the end of the day, the rand integer is the way to go. That's probably the one we would want to use. So to have access to those neat functions, we got to import the module. This is into global namespace. We're not changing the name of it. And this is actually a case where you might actually want to use the as keyword to specify the namespace, because the word random is going to be all over the place here. So random.random is going to give you access to that float value random, okay? And so when we multiply it just continues being a float value, okay? So that's kind of a bad thing to me. To use the rand integer, we have a starting point and an ending point, and some examples of how to do that. Random, we're calling the name of the module dot, and it tells us which function we're using in that module. This is just cleaner code to me. It's easier to read. And these are the random ranges, okay? So a little game here. We have die1. We're going to use the random module and rand integer function, and we roll a 6. We got a 6 on die1. Same thing again for die2. We got a 5, and we just print that out, and your roll was 6 and 5. We're going to expand on that concept in a minute, but that's a simple way to use random integers. So look at pages 125 and 126 in your textbook and look at the guess the number game. Read that code, understand that code, and you will get an idea of how a standard module like random works for us. Now, how do we plan functions for our program? We talked last time about pseudocode and my lack of a love affair with pseudocode. I got to work on that. I got to be more pseudocode, especially teaching this stuff. But you got to plan somehow. You got to plan somehow. And pseudocode helps you plan your logic flow. And that's important. Also, part of your plan has to be, how are your functions going to work? We have our pseudocode laying right here. So now we need to write a flow chart for all of our functions. And this is not hard. This is much easier than pseudocode is. And some of you might not have any problem with pseudocode. I saw several of you guys in our discussion forum talking about how great pseudocode is. And that's okay. I agree with you. It is great. It's tedious. I guess my OCD has a problem with it or something. I don't know. Anyway, we're just going to write a hierarchy chart. We're going to start at the top with the main function. And then under that, all of the functions that feed into that main function. And then there may be additional functions that feed into those. And it looks something like this. Okay. Very simple. Start with our main, then feeding into the main function. You saw before the display menu and the convert temp. And inside the temp, we had those, that if, else, if statement, if, else, if, else statement. And so we had these two functions up under it, okay? And here's how you could write that out with indentation, okay? So two ways to do it with blocks, or you could write it out. Either way, you got to chart it. You got to figure out which comes first, which comes second, which comes third. That'll help you with your chart. So always start with the main at the top, and the main's going to call your main lieutenant. I don't know whether I should get military here, but the functions that feed directly into that main, and then inside those functions, there could be more. So you're just dividing it down and getting more specific as you go down your chart, okay? Making this academic. I'm not an English teacher. It's a good thing because I can't spell and can barely talk. But just realize you start your names of your functions with a verb. Make them action words if you can. Okay. So the names in your chart should be verbs and what the function does. Now, it doesn't mean that you actually have to name your function whatever that verb is, but it will help your chart make sense, okay? That's what they're trying to say here. Make your chart readable. And certainly should be related to the function name. So you're going to have a hierarchy chart here for the pig dice game. And you're going to see the code for the pig dice game in your chapter. I'm not going to go over it today because we're already going overtime, okay? But you will see that the pig dice game flows this way. We have our main. Up under our main, we have display the rules and play the game. Now, when we play the game, we take a turn, and when our turn comes up, either we roll the die or we hold. So there's a lot of logic going on here. So this is the most general, okay? And then we have two, functions here that feed the main, and then these guys feed accordingly up the chart, okay? Not rocket science. So take a look at pages 130 through 133. You'll see a version of the pig dice game using global variables. Not such a good idea. I think you will like the code. It's a little bit maybe harder. Well, I don't say harder to read. That kind of defeats my purpose. But look at the code on pages 134 and 135 that uses local variables. That's where we're headed. That's what we should do, okay? And there's one little thing that's in pages 134 and 135 we haven't talked about. and that is the multiple assignment, okay? And it's just the ability in Python to set or assign more than one variable at a time. The syntax is variable name, comma, variable name, comma, variable name, comma, the assignment operator, and then the value for the first one, X, the value for X, comma, the value for Y, comma, and then the value for Z. These values have to be in the same order as the names. It is a possibility. I don't think this is a good idea either. I would rather write 3 different variables, because then there's no confusion and I don't have to worry about those values being in order. But that is in the example. It's also in our keywords for this chapter. So I wanted to make you aware of that. So go through the pig dice game, and that will be a good code review for you for unit number 4. So here's our list of terms, including that multiple assignment statement we just took a quick look at. Notice shadowing is in this list of terms. Namespace, I wasn't real excited about that, but we're learning. So namespace is one of our words. So understand all of these terms. And as you're studying, if you get crossed up, you can certainly Google it. If you're still crossed up, send me an email. I'll try to get you back on track. But make sure you understand these terms. Look over the summary. Once again, I've highlighted the terms in context here. Hopefully that will help. And the summary is a good way for a quick recap. I like the summaries in this book. I said that last week. So once again, what is our to-do list? Things to do this week. Read and study chapter 4. Download these slides. The latest and greatest slides were posted on Monday. So download these and add them to your collection, the Unit 4 slides. Go ahead and start working on the topic number 4 in our discussion board, and tackle lab 4-1 on pages 138 and 139. You're going to add to the future values program. You're going to enhance the future values program. Make sure when you submit this lab, you submit the enhanced version of your source code PY file. That's all I need. It's just the PY file for future values, the one that you, once you're finished making it better, okay? Take the Unit 4 quiz, and above and beyond everything else today, take the Unit 1 test, okay? Unit 1 test is going to be active until 11:59 tonight. Are there any questions, my friends? Let's see. David's got a question. Can you explain the purpose of calling the main function using the if statement again? I thought I understood it, but I'm confused again. If you attach the name of the module to the name of the function you're calling, attempt to, yeah, I got that. For example, how will main functions conflict? I think it's all about checking. Okay, I know this is it. The reason for the if statement at the end after the main function, to call the main function, is to check the internal name, the name that Python has in its memory bank. Okay, Python has a concept of the name of the program you are running. Okay, and it is going to run the main module in that program. Okay. So I don't want you to think that you solved the problem by referencing the module name dot function, okay, in your calling statements. That is required so that you get the right function out of the right module, okay. The if statement for the main at the bottom of the program is to make sure you're running the right main function. That's the difference. And it's very consistent. The whole rest of the course, you're going to see it over and over and over again. Does that help? I think this is the kind of thing that you might overthink until you do some coding. And David, I'm going to tell you what I would do if I was really wanted to see how it works. Write something from scratch. Write a module and then write a main program, import that module into it. Do the whole enchilada. It doesn't have to be a huge program, but write one from scratch and you'll see how it works. And then if you want to see what happens if you break it, be the master of your domain, break it and fix it, and you'll see it'll start making sense. What I'm trying to tell you is what the book says and what I know to be true, and a best practice, a set of best practices and how to be professional according to me in the book. Okay. And get you started. But it certainly doesn't hurt to, and if you don't want to write your own program from scratch, I'm sorry to hear that. But if you don't, make a copy of the files that come with a book and break those and see what happens. Testing is a good way to learn. I hope that helps. I don't know. Hope it does. Any other questions? Okay, fire away. Another question coming my way. He types fast. I like this. David is a much faster typer than I am. If you created a function using a global constant in a module and imported that module into a program, would the function not work properly in that program? Yeah, you're probably going to have a problem. I think you're going to have a problem because of the global constant missing. I think you're right. Once again, test it. See what happens. Okay. But I think that you're going to have a problem because that global constant is not going to come in when you import. I may be wrong. I'm trying to remember if I've ever done that exactly that way. I'm not a big fan of global constants either, but I see that they have a place. But to me, a global constant should only be used in the main and nowhere else. But you could have a global constants left over. I understand what you're saying. Absolutely. Yeah, I would definitely use local variables and functions you plan to import. I think local variables are going to be your friend. That's the most consistent thing that you should do. Good questions. Anybody else got a question? Well, I appreciate you guys hanging a little bit long with me today and asking good questions. That makes my job a whole lot more fun when I know what you guys are thinking. And I really appreciate you guys studying the chapters before class so that our questions can be as good as these questions. Really good questions today. So good luck on the test today. Let's hope Blackboard doesn't break, I don't know why I said that, but it has a tendency to break when tests are due. Don't know why. I guess it has a lot to do with everybody doing the test at the same time. That's why I try to spread it out. But anyway, no, Logan wants to know if we're going to run overtime next week. I think we're going to be able to stay within an hour and a half from the rest of the way out. Just depends on how chatty I get. Just remember that if you have to leave, I'm not going to hold you accountable for that. I'm not going to bust you if you have to leave early. I will post the video through the questions and all at the end. I will post that on my website so you can easily download that later and just speed to the end and watch the parts you missed. That's one of the great things about Zoom and recording these. I'm a big fan of Zoom, by the way. I'm thinking when we get back into brick and mortar, I'm going to use Zoom in my classes too. It is just that good. So, good question. Anything else? All right. Well, y'all have a great week, and I'll see you next Wednesday morning. And if you have any questions along the way, send me an email. Thank you, guys.